Hi everyone, and welcome to this Valohai webinar on version control in Jupyter Notebooks. I'm Fredrik, and together with me today I have...
Hey, I'm Juha. I'm a software developer at Valohai. And go ahead.
Yeah, so today we're going to look at basically Jupyter Notebooks, the most popular way of experimenting with machine learning. And one of the fallbacks of that is that it's very hard to keep track of what you've done and do version control for that. So we thought we'd start with that, maybe lay out the problem space first, and then look at a solution candidate for that, and also answer any questions that you have. So post your questions in the YouTube channel below, and we will answer them either live now or later on. So
yeah.
So let's get started.
Yeah, so you said we're going to talk about version control, but first I want to talk about something a bit more generic.
Yep.
I want to talk about workflows and specifically asynchronous workflow. And before you can talk about asynchronous workflow, you have to sort of explain what it is. And to explain it, you have to talk about synchronous workflow.
Yeah. And with the workflow, you mean like how somebody works, basically.
Yeah, how do you go about working? Like, what do you do first? What do you do after that? Some sort of process. You always have some sort of
as a data scientist or as a software engineer or something.
Yeah, I mean, it's everything, like even in gardening or cooking or whatever.
Yeah. You
always have some kind of workflow. So synchronous workflow is kind of the default workflow. So in creating something, so you do something, here it's modify, and once you've done something, you have to test it, then you get some information, then you modify it again, you test it again, and this cycle goes on and on. So that's synchronous workflow, right? So
both of our backgrounds are in software engineering, so yeah. This is quite typical in software engineering.
Yeah, sure. So the next slide is about software engineering. So in software engineering, synchronous workflow is you code. Once you're done, you wanna test if the code works, and then maybe it doesn't work. You have to fix it. You test again, code again, test code, test code, test. That's the cycle.
Yeah.
And just to demonstrate this, let's look how would typical software engineering with synchronous workflow work. How would it look like? So let's say my task here as a software engineer is I have some data and I need to draw some kind of graph out of the data. So what I would do is I would write some code. So this is the part of the workflow where I'm writing.
Yep.
This code doesn't really matter. It's just to demonstrate this point.
And then we run it.
Yeah.
We debug it or run it or compile it or whatever.
Yeah, right. So first you code, you write something, and then you test. That's one cycle. And now I would look at this graph, and maybe I don't like how it looks. So now another cycle starts. Now I'm writing code again.
Yeah. So as you saw, it took Juha like 1 second to get the results, but it's taking him at least 10 seconds to write some code again.
Yeah, so the ratio is quite clear that it takes 10 times more time to write this code than test it.
Yeah.
The testing is just one click, boom, it's done.
Yeah.
So that's, if you go back to the slides, what I was doing here, I would code, then I run it, I see the graph, I don't like it, I code again, I run it again, and so on and so on. So that's what I was demonstrating.
Yeah, and of course, some testing steps take a longer time than some other testing steps because they're more complicated. You have to maybe validate it with a real user or something like that.
Yeah, so this was really naive. Like most of the time, coding takes a lot more time.
Yeah.
Here it was 10 seconds, but I mean, it can be 1 hour.
Yeah, this could be, this x-axis here could be like 1 day or 1 week of work. It doesn't have to be like this.
For sure. But the testing is, in software engineering mostly, is really short.
Yeah.
Sometimes compile takes a bit of time, but that's really really rare. So the same thing in machine learning. It's a bit different.
Yeah.
So coding might take time. Sometimes it's very short. You just tweak one hyperparameter or something like that. But often the testing takes a lot more time.
Yeah.
So when we were coding there, the graph, it was just 1 click. I saw the results, done. But in machine learning, you have to train, and often the training takes could take 10 minutes, hour, 2 hours.
Yeah.
Are really long time to see if what you did is working.
Yeah, it's very much trial and error. That what you...
So it's also trial and error in software engineering, but testing is very short.
Yeah.
So in machine learning, the cycle is the same, but the time is very different. And let's look at how it would look like in machine learning. So here's a MNIST notebook. This is really simple code.
Yeah.
Again, the code doesn't really matter. We're just sort of defining this concept of synchronous workflow. So here I would run. I would run this code.
Yeah. So we are doing something here. It doesn't really matter what we're doing here.
Let's say we change the code. It doesn't matter. So now we're training. And now
we wait.
Yeah, now we wait. So in previous example with software engineering, it was instant. Here we have to wait. This is of course a bit naive example, but training a complex model would take an hour.
Yeah, or even a day. It depends on what you're doing. I mean, now we're going to maybe a few hundred steps or 100 steps apparently.
Yeah. So okay, let's say now I get some results. Let's imagine that took 2 hours.
Yeah.
And I make a tweak so the tweak can be really short, like just changing learning rate.
Yeah.
And now we have to run it again. So here we go. And now I have to wait 2 hours again, right?
Yeah.
So cycle is the same, but the usage of time is really, really different. And that's the point I'm trying to make here. So
yes. And this is very apparent, for instance, in like manual hyperparameter sweeps. This is sort of what you did there, but I mean, it's even true like outside hyperparameter sweeps as well, when you're just trying to find out what would be a good model for this data, for instance.
Yeah. A lot of machine learning is like this.
Yeah.
Of course, there are exceptions, and different models have difference of, like sometimes it's fast to get results, but often it's like this. So here's a quote from Edison: "The real measure of success is the number of experiments that can be crowded into 24 hours." So if you look at this machine learning what is it, time?
Yeah, the time
span. So you can see that if you wanna, let's say this is 24 hours, and we have like, I don't know, 7 experiments total.
Yeah.
And if you want to optimize this, how would that look like?
Yeah.
And the answer is kind of obvious, because the training takes so much time. You wanna optimize that.
Yeah.
And the answer is asynchronous workflow.
Yeah.
And so this is the whole point. This is where we're trying to get at. So asynchronous workflow would look like this.
Exactly. So you can do lots of time. I mean, the flip side is that you as a data scientist, you don't have as much time to just drink coffee and wait for your results anymore.
Right. So instead of like tweaking a hyperparameter and then start staring at the log output, drinking coffee, waiting for 2 hours.
It's very hypnotizing to stare at the log.
Yeah, for sure. It's like what do you call it? The casino machines. I don't know.
Or looking at the washing machine when it just goes around.
For sure. So that's not an optimal use of your time.
No.
So this is better, asynchronous workflow. So here, what you can see is like, if you look at this graph, we code something and we start training it. So that's one experiment. But while this first experiment is running, we can already start coding for the second one.
Yeah.
We're still solving the same problem. This is not like we have 2 models side by side. Well, in a sense we have, but we're solving the same problem.
Yeah.
And we start a second experiment, start training that one. We can start coding for the third one and training for that one, and this goes on and on.
So that's a very important point, because this does not mean that you do a context switch. You have the same context all the time. Yeah. You're not doing 2 or 3 or 4 separate works. Yeah. You're just trying out different versions of that sort of model space.
Yeah, so it could be like almost the same code. You just tweak one little thing,
yes,
start an experiment, tweak another thing, start an experiment.
Yes.
So the context is same, like you said.
So now the question is that if there only was a tool to make this possible, how would I do this in actual life?
Yeah, sure. So we have this tool to help with this asynchronous workflow, and next we're gonna look at that. So we have the same MNIST example, but this time we're gonna do it asynchronously.
Yeah.
And for that we have this extension or plugin, Valohai plugin, and maybe we should like explain what is Valohai a bit?
Yeah, so you'll see it later as well. I mean, just shortly, Valohai solves two problems. It helps you concentrate on your code and your data, just as we're looking here. It helps it by doing two things: automating machine orchestration, so you don't have to take care of ML ops or DevOps things. And secondly, it keeps track of what you have done. So you know that what you have done previously, you can roll back to any previous experiment that you tried out as well. You will see it in practice actually right now.
So previously when we were working in sort of the classic way, we would just run code locally here, like you can see I'm running code now. But what we're gonna do now is we're gonna do some changes. Let's change the learning rate back to this previous value. And then instead of running it here locally, we're gonna send this whole notebook to the Valohai and let it start training. And we can continue here with another experiment.
Okay.
So let's do that.
Sounds good. Sounds good.
So I just click here, and I click Create Execution.
Yes.
And this means in Valohai there's an experiment running now, and here we can see on the top right corner we have this number 1, which means this is our first experiment.
And this is by the plugin or the add-on for Jupyter Notebooks.
Yes. So we can see it's already running there. We can see this is a server log from Valohai. It's starting up a Azure instance.
Yeah, or whatever you have. So basically Valohai supports your cloud or your on-prem hardware. Yeah. So you have selected in the settings there that Azure Cloud is what we're using.
So it's running, and we don't have to stare at this. We don't have to wait for it to finish. So let's say I have another idea here. For now it's very nice.
Very innovative changes.
I'm just changing one variable. But let's say we like this new value and we're going to create another execution. And let's say I have another eureka moment and I want to change.
Innovative. Disruptive thinking.
That's for sure. And we're going to start a third execution or experiment.
And you can see here now, number 1 is already green.
Yeah. So green one is already done. So we can see the experiment has finished, and this was the final accuracy.
Yeah. So now we have done like asynchronously, we have started 3 workflows, but I actually forgot what was execution number 1. What was that?
You mean the learning rate?
Yeah, exactly. What was the learning rate and the code in?
Sure. So because this is finished, I can now sort of download the results. I click this blue notebook button here.
Yeah.
And what happens is that the notebook extension downloads the resulting notebook from the Valohai. So this is sort of the end result of the experiment.
Number 1.
Number 1, yeah.
Okay.
And if we go down here, we can see it was 0.003.
Yeah.
And hopefully there's some results. This is our...
So all the log files are here, all the graphs are actually drawn here as well.
Yeah. These graphs were created in Valohai, in the cloud.
So what Valohai does, it actually runs the entire notebook, not only 1 cell or 2 cells, it runs the entire notebook, all cells included.
Sure.
Okay.
And all our 3 experiments have now finished.
Yep.
And we could go here and download each one if we would want to continue working on, like we kind of branch out here, and then we choose which branch we will continue.
So if I open up, let's say tomorrow I come back to work and I'm thinking, what did I do yesterday? I can always see that, hey, I did these 3 experiments yesterday. I can open up any version of them at that point in time and I can compare. So it's sort of handy to compare that, but if there only was an easier way to compare the results as well.
Yeah, sure. So this is not the only way to sort of see or handle these experiments. So if, let's say I like this number 1.
Yeah.
So there's another button here, Valohai, and this button will open this experiment in the Valohai platform.
Yes.
So this is how Valohai actually looks like.
So now this is your first touch to actually Valohai.
Yeah.
You don't have to be here, but I mean it's nice to come here, and you'll see soon why.
Sure. So here we version control everything. So this experiment is version control. We can see a lot of data about this experiment here. So there's like which environment we used. We used Azure NC6.
Yeah.
And we used this specific Docker image.
So this Docker image includes the specific version of Python that we used and specific version of TensorFlow that we used. And
so 6 months later, we have everything version control. So 6 months later, if you would once you run this exact experiment again, it will work.
Yeah, so. And you wouldn't have to guess which version of TensorFlow did I use for this experiment. It has that Docker container there.
Yes. So. And there's more, like we have the hyperparameters here.
Yeah.
Their version control also.
Yeah, so I can see exactly those. Yeah. Yes. And I see you change your name to John Doe.
Yeah, I'm John Doe today. And here's the price and how long this took. And there's also more, like here's the server log. We already saw this, but you can also view it here. And 6 months later, this log is still here.
Yeah, which is pretty cool. I mean, any code that you run on Valohai gets all the log files get persisted always. Yeah. So you can come back to this now 6 months, 6 years later, you will see this exact log file for that experiment that you did.
Yeah, and there's a neat trick here because we are printing out this sort of JSON format.
Yep.
Our platform knows how to parse this, and 6 months later you can also look at this, like how did the accuracy develop here, and whatever you want to print out into the logs, we will parse it.
This looks a lot handier than looking at those printed out files in Jupyter Notebook.
Yeah, like imagine you have to open these notebooks one by one or something. Yeah. It's not really convenient. So this is sort of best way to compare.
Yeah.
And if we go back here, we can see all our 3 experiments here, and if we look at accuracy, we would compare it here.
Yeah.
If you want to find the best accuracy.
So this accuracy here on the right hand side, Valohai not only stores the metadata that you put in the output file and you can visualize it, but also it stores the last value. So you can see that in this experiment, looks like notebook 1 had 0.9 accuracy, notebook 2 had 0.91 and so forth. So you can see the best accuracy or the latest accuracy in that.
Yeah, and it's up to you how you print out the logs.
Yeah.
So
which is actually quite, if you open up the filter or actually the selecting what columns to have there. So all the ones, the accuracy, cross entropy and step, those are just there because your code happened to output them as JSON into the standard out.
Yeah, so if you look at the code here, it's here. So here we're printing out these values ourselves, and Valohai will parse these, and you will see this here or in the graph.
Yeah. So there's no integration to Valohai that you have to know of. The only thing you know of is you print JSON, and that's it.
If you know JSON, you know how to use this.
Everybody knows JSON.
Sure. So what else? Maybe we can show how the parameters are.
Yeah.
So how did the parameters get here? Because if we go back to our first experiment, for example, we can see that Valohai somehow knows that our learning rate was 0.003. And how is that possible? Because it was just code, right?
Yeah.
And we didn't print out the learning rate.
No.
So the way that is done is here's the cell that defines the learning rate.
Yeah.
And we've made this cell special. And the way we made it special, we are using this feature from Jupyter Notebook, which is called tags. I don't think many people know that this even exists.
Yeah.
I haven't met a data scientist that sort of knew about this feature.
Yeah.
But it's there, so if we look at tags, this is tagged as parameters. And parameters is a special tag that our plugin knows how to parse. And it knows that this specific cell will have all the parameters needed for this experiment.
Yeah.
So if I would write something here, I would write foobar, and we would start another experiment.
Then it will, if we could actually go into Valohai and even we don't have to,
Yeah, so we click here, we go to Valohai, this is our experiment number 4, and we can see foobar has appeared here.
Yeah.
And what is even more cool is that we can actually copy this one. So let's say this is 6 months later now. I come here, I press this copy, which means that I am now reproducing this exact experiment.
Yeah.
I can see foobar here, and that's my learning rate.
Yeah.
So I can even change the learning rate here, start another execution. So now we're actually using the notebook without even opening the
Exactly,
notebook
yeah.
because it was parameterized.
That's pretty cool. So if you now go into the project view again, we can see, or actually the demo tree, the entire project view.
Yeah, sure.
Then we can see that there's 2 actually going on at the moment.
Yeah, and for this 5, the latest one, we changed the learning rate.
Yeah.
Using Valohai, not from the notebook.
Yeah, exactly.
Yeah.
Exactly. That's pretty cool. I think so. I mean, shortly, there's not very much sort of rocket surgery involved here. I think everybody can understand what it does and the value of it. That you actually get version control within your notebook. You don't have to manually commit to Git any codes in between or anything like that. You just run your notebook. Every time you run it, it takes a snapshot of your notebook at that stage, and you can roll back to it at any time.
Yeah, so you get version control, but also you get the asynchronous workflow, right?
Exactly.
So you can run 5 experiments at the same time. You can still code your notebook. You don't, like with classic workflow, you have to wait. You don't want to touch the notebook because it's running. Like,
and you forget. I mean, even if you would do it synchronously in classic machine learning with Jupyter, you would still forget what you did five experiments ago.
Yeah, because every experiment kind of overrides the previous one. All the hyperparameters are changed.
Yeah.
So this version control is kind of automatic. You don't have
it's
to
automatic. You don't have to remember to take a snapshot, which is really cool.
Yeah, and even like let's say I create another one. That's experiment number 6. Let's wait for it to start.
Yeah.
Now it's starting. So if I would now take this laptop and throw it out of the window, the experiment will still be running there. I take another laptop from the store and install this, and it's still there running. So you don't forget to shut down your hosted notebook for 2 days and pay for it. Here you only pay for the time the experiment is running.
So good point. So just to say it in another way, the Azure instance that Juha here started, the 6th one is running at this moment here right now, but that's when it's completed, it's getting shut down automatically. So I'm not paying for the Azure instance after I've used it.
Right. You only pay for the time it actually does something.
Yeah.
You don't pay for the time you're writing code.
Yeah.
You shouldn't pay for that. Like
no.
Your expensive GPU is just waiting there.
Yeah, exactly. So how do you get started with this? So first of all, worth mentioning, we've been using Azure here. Valohai works on Google Cloud as well as AWS, as well as your on-prem hardware. So it works in your environment. But how do you get started? Maybe we should go to the website and just...
Yeah, sure. So like valohai.com.
Yeah. So the easiest way to do that is to create an account from the top right-hand corner. We don't have to do it now, but you can create it from there. After that, you can...
Sorry.
Yes, no worries. After that, you can contact us from the chat window in the lower right-hand corner there, and we will be happy to set up a demo or anything with you. And then going into Docs, just quickly, so you can click from the menu also on Docs. So from there, there's the instructions on how to get started with Jupyter Notebooks also. So it's very easy. It's just a Docker container that you install on your local machine. Hook it up with your Valohai account and you're ready to go.
Yeah, here's all the information you need to try this out.
Yeah, but I mean, if you have any questions at all, just send us your questions or then ask for a demo and we'll be happy to set up a demo. There were some questions beforehand here. So the first question was that, does this work with R Jupyter as well? Can I use some other kernels in Jupyter besides the Python kernel? And I think the answer is that not at the moment. We are building that at the moment.
Yeah, we're in beta, and in beta only Python works.
Yeah.
But in the final version, you can use R.
Yeah.
Or any kernel.
Any kernel at all.
Yeah.
Yes. So if you're happy to be our beta tester, sign up for the beta online as well, or just contact us through the intercom chat window, and we'll be happy to set it up for you. I think that's all we had today. Anything that you think we should add here still?
No, I think that was it. Yeah.
All right. Hey, thanks guys. Thanks for watching. Click the bell button underneath and subscribe to the Valohai channel. See you next time.
See ya.